Hi students. In the last lecture, we have discussed kinematics of SHM. Now in this lecture, we are going to discuss dynamics of SHM. We are knowing that acceleration of a particle is proportional to negative of displacement from mean position, right? So we have taken A equal to minus omega square into y. Now multiply acceleration with mass. Then see what we get. Mass into acceleration gives us net force. So net force equal to minus m omega square y. So here mass of the particle is a constant. Omega square is also constant. So that is taken as some constant k, which is known as force constant. Therefore, net force is equal to minus k into y. And we are knowing what is y here. It is a displacement from mean position. So this is now net force on the particle, which is equal to minus k into y. And if you're taking a spring block system, so in case of a spring, this k is equal to spring constant. So k is a general one, which we are calling as a force constant. In case of a spring, this k is equal to spring constant. So from here, k equal to m omega square. And from this, we can write omega value, that is k by m under root. And omega is 2 pi by t. I am writing here. Omega equal to 2 pi by, just a minute, it is right. Omega equal to, it is a 2 pi by t. And we got omega value root of k by m, that you can see here. K by m equal to root of, it is omega equal to root of k by m. So from that time period equal to 2 pi root m by k. So this is the expression we are going to use to calculate time period. This is a general one, time period of oscillations. And we can see now energy. So coming to kinetic energy, that is equal to half mv square. So earlier we have seen what is v, right? So v equal to a omega cos omega t plus 5. We can see here half mv square. It is v square, right? And we can see kinetic energy is now keep on changing with the time. So we are taking here average value. This is now average kinetic energy. So this symbol is stands for average value. So average value of kinetic energy is equal to half, so it is 1 by 4 m omega square a square. And how we got 1 by 4? So it is average value of cos square function in one cycle is 1 by 2. So this is what you are learning in mathematics. Average value for cos square function or average value for sin square function. For both values same. I am writing here that also. Average value of sin square theta. We are taking one cycle, okay? It is 1 by 2. That means we are taking 0 to 2 pi in one cycle. Average value of sin square or average value of cos square. Both are equal to half. Okay. So here you can see in the first one, k equal to half m b square. So in that a half m a square omega square constants. Remaining is only cos square function. And average value of cos square function is a half. So into half, then we get half into half 1 by 4. 1 by 4 m omega square a square. This is average kinetic energy. Okay, right. So here we have to focus 0 to 2 pi. What is the meaning of that? So here we are taking average value in one cycle. Getting the point. So one cycle means starting from mean to right extreme to mean position, from mean position to left extreme, and again back to mean position. This is one cycle. So in one cycle, average value of kinetic energy is 1 by 4 m omega square a square. Okay, right. Now coming to potential energy, it is equal to u naught plus half k y square. We have to focus very carefully. Earlier we have discussed that at mean position, potential energy is minimum, right? That is what I have taken here, u naught plus half k y square. If you observe, you can see in the first line what we got, f equal to minus k into y. So we have seen in case of a spring, f equal to minus k into x. It is now same form, right? See carefully, f equal to minus k into y. In case of a spring, f equal to minus kx. So we got spring potential energy half kx square. Using now same logic here, half ky square. So u naught potential energy at mean position plus half ky square. So that is now potential energy u naught plus half in the place of k m omega square y value a sin omega t y value. So y square. So a square sin square omega t plus y. Again, if you want to calculate average potential energy, you can see here u naught. It is a constant. So for a constant, average value remains the same value. So we have taken same. It is u naught plus for remaining part. Again, sin square is the only variable remaining half m omega square and a square. These are constants. So average value for sin square, it is a half. So half into half, it is 1 by 4. So again, 1 by 4 m omega square a square. Okay. And if you observe carefully, average value of kinetic energy 1 by 4 m omega square a square. Average value of potential energy u naught plus 1 by 4 m omega square a square. That means average value of kinetic energy is not equal to average value of potential energy. That one thing we have to focus very carefully. Average value of kinetic energy, average value of potential energy, these two are not same. They are same only if potential energy at mean position is 0, that is u naught 0. Okay, right. Now coming to total energy, means total mechanical energy is equal to potential plus kinetic. We can see kinetic how much? Half m omega square a square cos square function. You can see here potential energy u naught plus half m omega square a square sin square function. If you take sum of these two, u naught plus half m omega square a square, right? This is, we are calculating here we are calculating here total energy, which is equal to u naught plus half m omega square a square. Okay. So while you are calculating total energy, we have to focus very carefully What is k value given? What is a value given? If given total energy not equal to half k a square, you have to understand that minimum potential energy is not equal to 0. I'll do one thing. Let us take one small example here. I will write here. Suppose k value, take it as, let us take k value. It is 2 Newton per meter. A value, let us take 4 meter. Okay. And let us take total energy. See what is the value of half k a square. Half and 2 gets cancelled. A square 16. Suppose you are given total energy. It is now 20 joule. Okay. And see what is the value of half k a square. Half k a square is equal to half into 2 into a square, 4 square. It is now 16. So from this, what we can say? Given total energy 20, and we know k value given, a value given, half k a square value 16. That means minimum potential energy is equal to 4 joule. Okay, I am writing here. That implies U naught is equal to, it is a 4 joule. Okay. So whenever question is given, we have to calculate what is a half k a square and what is the total energy given. From that, we can decide is the minimum potential energy 0 or non-zero. Okay, right. Now coming to the last sentence here. Frequency. Frequency of kinetic energy and potential energy is twice the frequency of oscillation, and that of total energy is 0. See, what is the meaning of this sentence? So first understand what is the word frequency, where we use it. So here, whenever we are using the word frequency, it means it is changing periodically. Whenever a quantity changes periodically, there we speak about frequency. Okay. So here, I will draw a diagram here. Let us take, this is now mean position. And these are extreme positions. Extreme position. And this also extreme position. We are knowing that at mean position kinetic energy maximum. At extreme position kinetic energy is 0. So changing from maximum to minimum, minimum to maximum, maximum to again minimum, and minimum to maximum. That means kinetic energy is changing now periodically. Okay, in the same way, at mean position, potential energy is minimum. At extreme position, potential energy is maximum. Again coming to mean, potential energy minimum. Again coming to left extreme, potential energy maximum. Like this, potential energy also keep on changing periodically. Okay, that's why we are using the word here frequency. It is now frequency of kinetic energy and potential energy is twice the frequency of oscillation. See why it is given twice. See carefully why it is given twice. If you observe, one oscillation means mean to right extreme to mean to left extreme, and again back to mean position. This is one oscillation. In one oscillation, kinetic energy becomes two times maximum and two times minimum. Same thing, potential energy becomes two times maximum and two times minimum. Okay. So one minimum and one maximum. This is one cycle. That's why kinetic energy and potential energy, their frequencies are twice the frequency of oscillation. Twice the frequency of oscillation. I am repeating. In one cycle, potential energy becomes two times maximum, two times minimum. Same way, kinetic energy becomes two times maximum, two times minimum. That's why frequency of kinetic energy and potential energy is twice the frequency of oscillation. And that of total energy is zero. See, what is the meaning of frequency zero? Frequency zero means it is not changing. And you can see here, total energy is U naught plus half K A square. It is a constant. Total energy constant means it is not changing. Not changing means there is no frequency for that. That's why total energy frequency how much? Zero. Okay. Right. Let us now solve a problem basing on this. A particle is moving along x-axis under the action of a conservative force, and its potential energy as a function of position is given as U equal to 20 plus x minus 2 whole square joule, and given total mechanical energy is 36 joule. Find maximum kinetic energy. Find the position coordinates where potential energy is maximum. Also find position coordinate where potential energy minimum or kinetic energy maximum. Right? See, first one, kinetic energy is maximum when potential energy is minimum. Right? So you can see here the given function is given function is 20 plus x minus 2 whole square, right? And this will be minimum. So this will be minimum when x equal to 2, right? Therefore, minimum potential energy how much? 20 joule. And we are given total mechanical energy, that is 36, right? Given 36 joule. Therefore, remaining 16 joule, that is maximum kinetic energy. Okay, right. Coming to second one, find the position coordinates where potential energy maximum. So we know potential energy is maximum when kinetic energy is minimum. That is at extreme position, right? At extreme position, kinetic energy is zero. So kinetic energy zero means total energy purely, it is potential. So total energy how much? It is 36 joule. Okay, which is maximum potential energy. Okay, and you're asking position coordinates, and calculation of position coordinates requires what is amplitude. Or here you can see x equal to 2, potential energy minimum. That means x equal to 2 meter corresponds to mean position. Okay. If you want to coordinates where potential energy maximum, then what we can do is, I will draw a diagram here. Mean position corresponds to x equal to 2. Suppose amplitude is a, then one coordinate becomes one coordinate becomes, it is a 2 plus a. Other coordinate becomes left extreme. Left extreme becomes, it is 2 minus c. Those are the coordinates where potential energy is maximum. Okay. Right. Now see the last one. What is, find the time period of oscillations. So to find time period, what we are doing is find the force F equal to minus du by dx, right? Then see what we get. Minus 2 into x minus 2, right? So this is of the form. This is of the form some k into x, right? So in the place of k, it is now 2. So here, what is the force constant? It is a 2 Newton per meter. Therefore, time period is 2 pi root m by k. If mass is known and k is known here, then time period is known. If you want frequency, take reciprocal of time period. That gives us a frequency of oscillation, right?